All right, let's talk about what is quickly becoming the single most important skill for anyone building with AI. And no, it's not just about writing clever prompts anymore. We're going way deeper than that. We're talking about designing the very architecture of how an AI thinks. Welcome to the world of context engineering. So let's start with a problem that, well, if you've worked with AI, you've definitely felt this pain. You're trying to get a powerful model to do a complex, multi-step task, and suddenly, it just completely loses the plot, right? It forgets what you said earlier, starts hallucinating, gets totally distracted. So what's going on? Why does this happen? The whole answer is wrapped up in how an AI remembers. And to understand that, there's this fantastic analogy from Andrej Karpathy that just nails it. Think of the large language model, the LLM, as the computer's CPU. It's the brains, the raw processing power. But that powerful processor is useless without working memory. For an AI, that working memory, its RAM, is something called the context window.
So what exactly is a context window? Simply put, it's the AI's short-term memory. Imagine you're reading a massive, ancient scroll, but you can only look at it through this tiny, fixed-size window. You can only see and process the words that are right there in the frame. As soon as you scroll down, the text that was at the top, it's gone. Out of sight, out of mind. That is exactly how an AI's context window works.
And this is where all the trouble begins. When that working memory gets too crowded, the AI's performance just tanks. It can get confused by old, irrelevant information. It can get distracted from the main task. Or even worse, it can suffer from context poisoning, where it starts treating an earlier mistake or hallucination as a fact. The bottom line is this: managing this limited memory is everything. So clearly, the solution here isn't just about trying to find some magic words to put in a prompt. We need a much more structured, architectural approach. And that's the fundamental difference we're talking about. Prompt engineering is all about the phrasing. Context engineering is about the architecture. It's about deliberately designing the entire information ecosystem that the AI is living in, what it sees, what it's allowed to remember, and what tools it can access at any given moment. Now, I know what you might be thinking, but wait, context windows are getting huge now, and you're totally right. I mean, the jump has been absolutely dramatic. We've gone from a couple thousand tokens in early models to now over 1 million. But here's the kicker. Bigger RAM doesn't automatically mean a better computer. In fact, a larger, unmanaged context window can make problems like distraction even worse. It just gives the AI more room to get lost. And hey, don't just take my word for it. The folks over at Cognition AI, the team behind Devin, that AI software engineer everyone's talking about, they put it really bluntly. They say that context engineering is, and I'm quoting here, effectively the #1 job for engineers building AI agents. That's a pretty big deal. Okay, so if this is the #1 job, how do we actually do it? Well, thankfully, we can break this whole complex idea down into a really clear 4-part strategy. The entire toolkit really boils down to just these 4 actions: write, select, compress, and isolate. You can think of these as the 4 fundamental moves you can make to manage an AI's working memory. Let's break down each one. We're going to start with the first 2, write and select, because they're all about controlling the flow of information, what goes out of the context window and what comes in. So, first up is write. The idea here is so simple but so powerful. Stop forcing the AI to keep everything in its head. You need to give it a way to save important stuff externally. It's basically like giving the AI a notebook and a pen. In practice, this looks like a couple of things. You could give an AI a scratchpad, which is just a temporary place for it to jot down its plan or calculations for the current task. Or, for things you want it to remember forever, you can have it write to a memory store. That's how it can remember your name or your preferences across totally separate conversations. Okay, so if write is all about getting information out of the short-term memory, select is its perfect partner. It's the art of pulling only the most critical pieces of information into the context window at the exact moment they're needed, while keeping all the other noise out. And this is where some really powerful techniques you've probably heard of come into play. RAG, or Retrieval-Augmented Generation, is a classic example. It grounds the AI by fetching relevant facts from a database. Or, instead of overwhelming an agent with 100 possible tools, you can just selectively load the 3 it needs for this exact step. It's all about focus, and it makes a huge difference in accuracy. All right, we've covered getting information in and out. Now, let's talk about how to optimize the stuff that's already inside the context window, and what to do when problems get really, really big.
Strategy number 3 is compress. Think about it. As a conversation goes on, the context gets filled with, well, a lot of fluff. Compression is all about trimming that fat. It's about making the information that's in the window as dense and useful as possible, without wasting a single token. A really clever way to do this is to use another LLM call to just summarize the conversation so far. You can replace thousands of tokens of back and forth with a few hundred tokens of a tight summary. Or there's a simpler approach. Just automatically trim the oldest messages once you get close to the limit. It's a simple trick, but it's super effective at keeping AI focused on what's happening now. And that brings us to our final strategy: isolate. Look, for really complex problems, trying to solve them in one gigantic, messy context window is just asking for trouble. A much smarter approach is to divide and conquer. This is the thinking behind powerful designs like multi-agent systems. You create a whole team of specialists. You have a planning agent that figures out the steps, and then it hands off a subtask to a research agent or a coding agent, each one working in its own clean, focused context. Another way is to use a sandbox for messy jobs, like running code. The main AI stays clean, and it only gets the final polished result back. So let's pull this all together. We've got our 4 strategies: write, select, compress, and isolate. But why does mastering this stuff really matter so much? What's the big payoff? Well, the payoff is massive. When you properly engineer the context, you dramatically cut down on hallucinations. You make it possible for an AI to actually handle long, complex tasks without getting lost. You can build systems that genuinely remember users and create personalized experiences. This is the stuff that separates a simple toy chatbot from a reliable, efficient, and truly useful AI agent. Which leaves us with one final big question to chew on. As the underlying models themselves just keep getting more and more powerful, maybe the real art and science of building great AI is less about the model itself and more about the intelligent, elegant, and efficient context systems we build around it. Something to think about. Thanks for watching.